Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Gear Patrol calls their new dive watch the best sub-$500 dive watch. Full stop. Men's Health rated them as the most stylish solar watch in the game. Who are we talking about? It's Movement. They're leveling up your gift giving with the sleekest watches you can buy and the biggest deals of the season. Shop 30 to 50% off Movement's innovative California clean watches, jewelry, and accessories with fast free shipping and returns now at mvmt.com. That's mvmt.com.
This is SpaceTime, Series 24, Episode 39. Coming up on SpaceTime, ocean currents predicted on the ice moon Enceladus. SpaceX's SN11 test ends in another explosive failure, and Southern launch granted a space license by the Australian Space Agency. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that ocean currents are churning in the subsurface seas of the Saturnian ice moon Enceladus. The findings, reported in the journal Nature Geoscience, are based on the shape of Enceladus's 20-kilometre thick ice shell. The new hypothesis challenges current thinking that the moon's global ocean is homogeneous, apart from some vertical mixing driven by the warmth of the moon's core. Enceladus is a tiny frozen snowball just 500 kilometres wide. That's just a seventh the size of the Earth's moon. It's the smoothest body in the solar system, as smooth as a cue ball. Enceladus attracted the attention of scientists in 2014 when a flyby by the Cassini spacecraft discovered evidence of a large subsurface ocean after water was seen spewing out of geyser-like eruptions through fissures in so-called tiger stripes in the ice near the moon's south pole. A spectral analysis of the water by Cassini indicated that it was salty. Together with Jupiter's ice moon Europa, Enceladus is one of the few locations in the solar system other than Earth with liquid water. And that makes it an obvious target of interest for astrobiologists searching for signs of life. But the oceans on Enceladus are almost entirely unlike those of Earth. Earth's oceans are relatively shallow, with an average depth of just 3.6 kilometres. They cover about 3/4 of the planet's surface, and are warmer at the top thanks to the sun's rays, and cooler at depth near the seafloor. And they have currents that are affected not just by the spin of the Earth, but also by wind. On the other hand, Enceladus appears to have a global spanning and completely subsurface ocean that's at least 30 kilometres deep, is cooler at the top near the ice shell, and warmer at the bottom thanks to heat from the moon's core. Despite their differences, the study's lead author Anna Lobo from Caltech says the oceans on Enceladus do have currents based on the Cassini measurements and observations on Earth, looking at the way ice and water interact to drive ocean mixing around Antarctica. Lobo says the oceans of Enceladus and Earth share one important characteristic: they're both salty. And variations in salinity could serve as drivers for ocean circulation on Enceladus in much the same way they do in Earth's southern ocean around Antarctica. Gravitational measurements and heat calculations from Cassini have already revealed that Enceladus's ice shell is thinner at the poles than the equator. That's why the tiger stripes are located there. Regions of thin ice at the poles are likely associated with melting, and regions of thick ice at the equator with freezing. And that affects ocean currents, because when salty water freezes, it releases salts and makes the surrounding water heavier, causing it to sink. And the opposite happens in regions of melt. Knowing this distribution of ice allows scientists to place constraints on circulation patterns. Computer models based on Antarctica suggest that the regions of freezing and melting identified by the ice structure would be connected by ocean currents. And that would create a pole-to-equator circulation pattern which would influence the distribution of heat and nutrients. Understanding which regions of the subsurface ocean on Enceladus might be the most hospitable to life as we know it could one day inform efforts in the search for signs of life there. This is SpaceTime. Still to come, SpaceX's SN1 test article ends in another explosive failure, and the Australian Space Agency grants a commercial license to Southern Launch. All that and more coming up on SpaceTime. They say space is hard, and the latest SpaceX Starship test flight has once again proven how true that saying is.
In the fog is SpaceX's Starship test vehicle number 11. It was just over 3 weeks ago we launched number 10 from the adjacent pad at the Starbase facility in Cameron County, Texas. For today's test, we are counting down to launch of Starship number 11 to a 10-kilometer altitude. Now, as with our last test, today's flight is to gather data on using flaps to control Starship as it descends back to the landing pad before lighting its Raptor engines for touchdown. Fog is everywhere at Starbase in Texas.
T-minus 2 minutes.
T-minus 2 minutes and counting. We have completed propellant loading, both the methane fuel and the liquid oxygen on board Starship test vehicle number 11.
T-minus 1 minute.
We're counting down. We are retracting the quick disconnect from the vehicle in preparation for launch.
T-minus 30 seconds.
Good preval cycles.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Following its launch from the Boca Chica test range in Texas, the unmanned SN11 prototype reached an altitude of 10 kilometers and began a planned series of maneuvers.
T plus 33 seconds. Starship test vehicle number 11 ascending over Starbase in South Texas.
1 kilometer altitude.
We've heard the call out. We're over 1 kilometer up.
4 kilometers altitude.
T plus 2 minutes. We're getting ready to shut down the first of the 3 Raptor engines. We have shut down the first of the 3 engines on time as planned. Continuing to climb on power of 2 engines. We're past 8 kilometers. We have shut down the second of the 3 engines as planned. We're now slowly climbing to the final 10-kilometer altitude on the power of the single Raptor engine. Once we're at apogee, we'll hover shortly, shut down the engine as we flip over, and then descend back towards the landing pad at Starbase.
10 kilometers altitude.
Coming up at T plus 4 minutes, we're at 10 kilometers altitude, and we are getting dropouts on the camera, but we continue to get telemetry from the Starbase, from the Starship vehicle.
It then began a horizontal descent back towards the surface.
While we're waiting to reestablish video connection with the vehicle, we have shut down the third of the 3 Raptor engines as planned. We're now beginning the horizontal maneuver back down to the landing pad at the Starbase facilities. As we get close to land, we will ignite the 3 Raptor engines, flip to vertical, and then land on the thrust of a single Raptor engine. T plus 4 minutes, 40 seconds and counting, and it looks like we've got some camera views back again.
6 kilometers altitude.
T plus 5 minutes.
1 kilometer altitude.
However, 5 minutes and 49 seconds after liftoff, all the cameras aboard the spacecraft suddenly froze, just as the test article's 3 Raptor engines began to reignite for the flip to a vertical landing configuration.
T plus 545, we've just passed through 1 kilometer altitude, getting ready for the relay.
The vehicle then exploded in midair, or as SpaceX likes to call it, experienced a rapid unscheduled disassembly.
We lost the clock at T plus 5 minutes, 49 seconds. Looks like we've had another exciting test of Starship number 11. A reminder again, this is a test series to gather data on entry of the Starship vehicle at subsonic speeds as it comes back to the landing zone. It does appear, though, that another exciting test, as we say. We don't have any good camera views to share with you right now, so with that, we are going to bring the webcast to a close. A quick recap, we had the nominal ascent, we maneuvered the horizontal when we got to 10 kilometers. The entry, we had some nice views from the exterior camera showing the flaps were quiet as we descended, but then we had the camera freeze up as we got into the engine ignition sequence, and so we're going to have to find out from the team what happened. Starship 11 is not coming back, do appear to have lost all the data from the vehicle, and the team, of course, is away from the landing pad. So we'll be out there seeing what we had. Interesting flight, and as always with Starship, an exciting time on our webcast.
SpaceX boss Elon Musk later tweeted that Raptor Engine 2 had issues on ascent and didn't reach operating chamber pressure during the landing burn, but pointing out that theoretically it wasn't needed. He then concluded that something significant happened shortly after the landing burn began. Musk says the next batch of Starship prototypes will be upgraded versions of the current prototypes, starting with SN15, which is likely to be the next to fly. Of course, Starship's really only the upper stage of a two-stage launch vehicle. The lower stage, known as the Super Heavy, is also getting ready for its first test flight, engineers deciding that the first prototype to fly will be the second test article, not the first. This is SpaceTime. Still to come, Southern Launch granted a space license, and another 60 Starlink satellites launched into orbit. All that and much more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Following 2 test flights last year, Southern Launch has become the first private Australian company to secure a launch facility licence from the Australian Space Agency. The approval for the company's Canimba test range follows 2 successful launches in September last year. The Canimba test range is located 40 kilometres northwest of Ceduna on the South Australian far west coast. The licence will allow Southern Launch to fly rockets into space and recover payloads in the uninhabited desert to the north. Southern Launch is also developing an orbital launch facility at Whalers Way on the Eyre Peninsula near Port Lincoln. SpaceX has launched its 23rd cluster of Starlink broadband communication satellites. The flight aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida carried another 60 satellites into orbit. The mission brings the total number of Starlink satellites launched to more than 1,385, with current plans calling for more than 30,000 satellites to eventually be flying. The mission also marked the 6th launch and landing of the same Falcon 9 first stage booster. The rocket had previously been used for the launch of the GPS-3 Space Vehicle 3, the Turksat 5A telecommunications satellite, and 3 earlier Starlink missions.
Starlink is a constellation of satellites that can provide high-speed, low-latency internet all over the globe, particularly in remote areas where connectivity is limited or completely unavailable. Today, roughly half of the world's population, or nearly 3.6 billion people, don't have access to the internet. If you've been following our Starlink's progress, you'll know that Starlink beta service is now available in the United States, Canada, the United Kingdom, Western Germany, and the South Island in New Zealand. As we launch more satellites, install more ground stations, and improve our networking software, data speed, latency, and uptime will all improve dramatically. And with every Starlink launch, we get closer to our goal of nearly global coverage of the populated world. All systems are go for an on-time liftoff this morning. Once Falcon 9 lifts off of the ground, our first and second stages will separate about 2.5 minutes into flight. The first stage will then return back to Earth to attempt its 6th landing, this time on our drone ship, Of Course I Still Love You. And while that's happening, our second stage will continue on its journey. In order to get our satellites to the intended orbit today, we have 2 coast phases. We'll be igniting our Merlin vacuum engine twice, with the deployment of our Starlink satellites around the T+1 hour and 4 minute mark. Let's take a closer look at the rocket Falcon 9, our 2-stage liquid-fueled rocket. It's 70 meters tall, greater than the wingspan of a 747 aircraft. We are flying today's booster for a 6th time. This rocket first flew on the GPS-3 Space Vehicle 3 mission in November of last year, followed by 2 Starlink missions. In 2021, it supported the Turksat 5A mission in January and another Starlink mission in February. The bottom 2/3 of the vehicle is the first stage. The first stage's job is to accelerate the vehicle through the Earth's atmosphere into space, with the help of 9 Merlin engines at the base of the rocket. And on top of the first stage is the black carbon fiber inner stage. And then on top of that is the Falcon 9 second stage, which has a single Merlin vacuum or MVac engine. Once the first and second stages separate about 2.5 minutes into the mission, the MVac engine will ignite and carry the Starlink satellites into an elliptical orbit around the Earth. And at the top of the rocket, a large nose cone, that's where the stack of Starlink satellites are safely enclosed. The fairing protects the satellites from aerothermal heating, aerodynamic loads, and contamination during ascent. Once we reach the vacuum of space, we will jettison the fairing halves as the second stage continues its journey into orbit. It will be the second flight for today's fairing, and we're going to be attempting to recover each half again in what we refer to as a wet recovery, which just means that we'll be retrieving each from the water. Falcon 9 has been loading propellant since the T-minus 35-minute mark. We use a rocket-grade kerosene known as RP1 for our fuel and super chilled liquid oxygen, or LOX, as our oxidizer to power Falcon 9. Currently, RP1 and LOX are nearly fully loaded on both stages, and LOX will continue to be topped off right until the final minutes of the countdown. The latest weather report is 90% favorable for liftoff, and weather conditions also look good for booster recovery as well. With that, the vehicle, satellites, weather, and range are all looking good for an on-time liftoff just a few minutes from now. Falcon 9 is now moving into the final stages of the countdown. We're currently waiting for the transporter erector, or TE, to retract away from Falcon 9. First, the TE clamp arms will open up, and then the transporter erector will begin to retract away from the rocket slightly. And you just heard the call out that we are beginning that process. At T0, the hydraulics will pull the TE farther away from Falcon 9 as it lifts off. The transporter erector has a couple of jobs. It provides liquids, gases, electrical connections to the second stage, as well as air conditioning to the payload fairing. Clamp arms are now open at the top of the vehicle. Falcon 9 is in startup. This means that the rocket's autonomous internal flight computers have taken over the launch countdown. The range has cleared the surrounding ground, water, and airspace, and are also green for launch. This is the 9th mission for SpaceX in 2021 and the 23rd Starlink mission.
Falcon 9's in startup.
We are in startup. This means that the first and second stages are beginning to pressurize for launch. In just a few seconds, we should hear the launch director give the final go for launch.
Falcon 9, Starlink LD is go for launch.
All systems are go for launch. Let's listen into terminal count and watch as Falcon 9 takes our 60 Starlinks into orbit.
Vehicle is pitching downrange.
Stage 1 chamber pressure is nominal.
Power into telemetry nominal.
We're just under a minute into flight. Falcon 9 has successfully lifted off from Pad 40 at Cape Canaveral Air Force Station, carrying our Starlink payloads into orbit. In just a few seconds here, we should be...
Vehicle is supersonic. Vehicle is now experiencing maximum aerodynamic pressure.
And there's the call up for Max Q. In about a minute, we have 3 events happening back to back. First up is main engine cutoff, also known as MECO. This is where all 9 M1D engines shut off to slow the vehicle down in preparation for stage separation.
Engine has begun.
The second event is stage separation. This is where the first and second stage will separate from one another, with the first stage making its way back to Earth for a landing attempt, while the second stage continues its journey with the third event, second engine start 1, also known as SES-1. This is where the single Merlin vacuum engine on the second stage will light up and propel the second stage along with the Starlink satellites into orbit.
Main engine cutoff.
Stage separation confirmed.
And we had successful main engine cutoff, stage separation. The engine on the second stage has successfully started up.
Trajectories.
Now we're expecting fairing deploy here in a couple of seconds.
Fairing separation confirmed.
And off come the fairing halves. That call out and the visual confirmation means that we've had successful fairing deploy. We are at T plus 3 minutes and 50 seconds into flight. The Merlin vacuum engine on the second stage glowing red hot. As the second stage heads towards its drop-off orbit, stage 1 will execute 2 burns in order to make its way back to Earth.
Acquisition of signal, Bermuda.
The first is an entry burn where 3 of the Merlin engines will reignite, and this will help to slow the stage down as it re-enters the upper parts of the atmosphere. The second burn is the landing burn. This is a single engine burn that brings the vehicle speed down rapidly in order to land on the drone ship. The Merlin engines on the first stage are optimized for sea level, and they can achieve 190,000 pounds of thrust during ascent and descent. The Merlin vacuum engine is optimized for the vacuum of space.
Both vehicles continue to follow nominal trajectories,
producing over 220,000 pounds of thrust in a vacuum.
Stage 1 FTS is safed.
Stage 1 entry burn startup.
And we have successful stage 1 entry burn start. This burn is going to last for about 20 seconds.
Stage 1 entry burn shutdown.
Both vehicles continue to follow nominal trajectories.
4 hypersonic grid fins have deployed near the top of the first stage. The stage 1 uses nothing but these grid fins for steering as it makes its return back to Earth. They orient the rocket during re-entry and guide the rocket during descent. During the entry burn, the first stage landing legs will deploy. We have 4 of them on Falcon 9 first stage, and they're made up of state-of-the-art carbon fiber with aluminum honeycomb. They're placed symmetrically around the base of the rocket and will deploy just prior to landing on our drone ship today.
Stage 1 landing burn startup.
Now we're waiting on second engine cutoff of the second stage, and then shortly after that, we're expecting to hear confirmation of a good orbit.
Seco.
Expected loss of signal, Cape Canaveral.
Nominal parking orbit insertion.
Stage 1 landing confirmed.
We did indeed land the first stage. That is the 6th. This is the 6th time for this booster.
FTS is safed.
And the 78th successful recovery of a Falcon 9 first stage. Now the second stage is going to coast in this orbit for the next 35 minutes or so.
This is SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study shows that chemicals present in white button mushrooms could slow the progression of prostate cancer. The male sex hormone androgen promotes the growth of prostate cancer cells by binding to and activating the androgen receptor, a protein that's expressed in prostate cells. But a report presented to the Endocrine Society's annual meeting suggests that white button mushrooms appear to suppress the activity of the androgen receptor. Scientists had previously conducted a phase 1 clinical trial of white button mushroom powder in patients with recurrent prostate cancer, which indicated that the mushrooms reduced the level of prostate-specific antigen in the blood with minimal side effects. A sudden change in blood levels of prostate-specific antigen in men may indicate the existence of prostate tumours. The new research found that white button mushroom extract suppressed antigen receptor activity in prostate cancer cells, but scientists are yet to determine why it's happening. A new study warns that the critically endangered regent honeyeater is losing its song culture due to the bird's rapidly declining population. A report in the Proceedings of the Royal Society Bee claims that just like people learning to speak, many birds learn to sing by associating with older birds of the same species. The findings by scientists with the Australian National University suggest that the birds risk losing this skill if adults become too rare. And if they don't learn to sing an enchanting enough song, their chances of mating are reduced. China has doubled the number of endangered species on its list of wild animals under state priority conservation. A report of the journal Nature says it's the first time any animals have been added to the list in 32 years. While many of the newly protected species of birds, wolves were also given protection. Harming any of the 980 species on the updated list would result in significant fines. Beijing says the list is now being updated every 5 years. A new study has found that when it comes to politics, around 1 in 5 Australians now consider themselves to be non-partisan, with levels even higher among young Australians. A report in the Australian Journal of Social Issues found that people who are non-partisans tended to pay less attention to politics and were more likely to decide who to vote for on the day of the federal election or to submit an informal vote. The research found that young people showed especially high levels of non-partisanship, with around 1 in 3 saying they didn't support any particular political party. The study's authors say the relatively low levels of engagement among young non-partisan Australians indicate that some so-called quiet Australians may be quiet because they're not very interested in hearing about, reading about, watching or engaging in politics, and therefore simply have very little to say on the matter. It's been revealed that immunisation rates of 2-year-old children in the hippie communities around Byron Bay, Mullumbimby and Nimbin are running at just 63.6%. That compares to the New South Wales state average of 91.4%. The Northern Rivers region of New South Wales has become infamous as a hotspot for the anti-vaccination movement, with by far the lowest immunisation rates in Australia. Tim Mendham from Australian Skeptics says those decisions carry real and sometimes fatal consequences for the most vulnerable, with young children dying of preventable diseases.
Mullumbimby is sort of like a hippie New Age area that a lot of people from the 70s and things moved up there to get away from the rat race, and fair enough. And they took a lot of their New Age ideas and everything, and some of those fine, some of them are not. They are very, very strongly anti-vaccination for various reasons. Obviously, they just see it as part of the big pharma conspiracy, etc., and they're prone to all the conspiracy theories and that sort of thing. The trouble is that the vaccination rate, therefore, in the area, now not everybody up there is a New Ager by any means, but there's a lot of people who've been up there a long time, lived most of their lives or all their lives up there for generations perhaps, but the vaccination rate in that area overall is about 60%, which is the lowest in Australia. A lot of places in Australia, state averages, etc., are often in the 90s. 92, 93, 94, 95, which is a good number for getting herd immunity. But when you only get 60%, you've got a lot of problems with diseases coming in. And that was particularly the case with some babies, one in particular who died after a few weeks of being born because they can't be vaccinated. Well, at that stage, they couldn't be against whooping cough or pertussis. And they caught that from obviously someone within the community who hadn't been vaccinated, and with dire effect, as bad as you can think. So what happens now, it would tend to be with whooping cough, is you can get a vaccination during pregnancy for the mother. That helps give the baby some sort of immunity. But the trouble is, there's a lot of people who can't be vaccinated. They're compromised immunity, which means, not through any fault of their own, not through any choice, it's just that their body won't take it, so they can't be vaccinated. So you have to rely on everyone else being vaccinated to protect them. And everyone else who doesn't get vaccinated is probably doing it by choice. And if you get a high enough percentage of them, diseases such as measles and pertussis and things, mumps, things like that, which are vaccine preventable. Now, not all vaccines. Vaccines have a variable efficacy rate. There's none that is perfect. Some people do have reactions to them, sometimes bad reactions. But overall, it is better to be vaccinated than not, because the effects of getting one of these diseases can be a lot worse than getting minor symptoms, whatever they might be, through immunisation. So when you get a lot of people gathering together, unvaccinated, you're just asking for trouble. It's a dangerous situation to be down that low in the vaccination rate, and that's the lowest in Australia.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.